have about 15 minutes for Q&A. I wanted to thank the presenters. Those were all really interesting and thought-provoking presentations. I did want to start with one question to Philip. And the last project, the number 3 one, is it getting built?
No.
Oh, no.
So it's a competition that we didn't win.
Oh, darn. That would have been nice to see.
You're upset about it. How do you think I feel?
Yeah, I can imagine you'd be much more upset. From the audience. Phil?
Hi, a question for Phil. The one project that is currently under construction, I'd like to know where is the timber sourced from and where is it being manufactured into CLT panels?
I believe most of the timber is coming out of Europe. I think some is being sourced out of New Zealand. And Lendlease have built their own CLT plant in Australia. So it's being imported in mass and then being then put into the final panels in Australia.
Can the panel respond to just a simple question as to why is most of this coming from Europe, and why is the CLT not tending to be manufactured elsewhere, because trees grow everywhere?
I think it's primarily just the history. So a lot of this technology was developed in kind of Central Europe, and there are lots of trees there, and the technology is just a little bit more mature. The supply chains are a bit more mature. I don't think there's any technical reason why you couldn't do this in most places that produce
because if
trees.
we're really trying to push lowering the carbon, it's easier to sell something that's not shipped,
Sure,
like around to the other side of the world.
Oh,
You know,
I quite
in
agree.
terms of the overall embodied energy of the product, then.
I think it's about getting the economies of scale. So there's only been 3 or 4 buildings, Rob might correct me, built in Australia, but the market is building up, and once there's a reasonable critical mass, the industry will be able to manufacture here. I think that is the end goal.
Yeah, I think, I mean, just to add to that, I mean, we've been on the framework project, we reached out to maybe 8 teams globally to look at, who could do the project and how they could best sort of deal with that. We also looked at their carbon footprints in terms of how that material would be transported. But, there's 14 manufacturers of CLT, in Central Europe, and the reason is there's demand, and I think that there was a certain amount of support from the Austrian government to get it going. I think that type of support is needed elsewhere to kind of prime the pump so that people feel confident that they can actually, 1, build the buildings, under code, and 2, really kind of have a business model that's profitable. We know of, a number of plants that are about to go online in the United States. I would say, just indirectly, I know of 3 or 4, and then we also have stuff and it's going to take a while because you're talking about a $20-30 million investment to kind of get those types of plants up and running. So it's a big ask, and I think, that's a big part of it.
Terri. Oh, Phil Gardner, Consult. Just to help answer that question, there is a plant just being built on the border between New South Wales and Victoria that's about to go into production about now by a company called Xland, and there is one in Perth in Western Australia. So they are a big investment. The other problem the other issue we have here is most of our forest is native hardwoods, slow growing, and not we don't like to cut it down. Unless it's for good purpose, and our softwood plantations, radiata pine, aren't maybe as good as the European softwoods, but that is what we'll be working with. In Western Australia, they have a very old plantation that was put on water catchments that's about 50 or 60 years old that the government wants to get rid of and replace with native forest, and they've been given that, and they've got about a 40-year supply of timber for a plant over there. So we will be making it locally.
I suppose my question would be Thomas, given that you've done so many projects. With regard to durability of the material and maintenance, what sort of actions do you take? Are you so bold as to let it sort of naturally weather? Does it need to be encased? Are there any sort of coatings you apply on it, and what periodic sort of maintenance do you need to apply?
I mean, I think it's really good to look at old wood buildings historically. So I was just in Japan over the summer, and Norway as well. I mean, they have buildings that are 800 years old plus out of wood. There are, I think in our case, where we're working in a very rainy climate, we're building in the rain. One of the key aspects of these buildings is the sort of quality of the CLT, so meaning the pressure of the press and also adhesives that are used, so that it's really critical that you reach the certain amount of pressure to make sure CLT doesn't have an issue when it gets wet. So that's an issue with glue-lams and lamination. One of the things we do with our building is there was no finishes on any of the wood. There was just a simple clear sealer in the factory. And we actually, there was no sanding after the building was complete. So basically what we did is, one of the reasons we use those powder-coated connections or galvanized connections is we allow the sort of dirt to run through the building, and then we use what's oxalic acid, which is a wood bleach, to basically take the dirt off these beams. The other key thing that we're doing is, as we dry out the building, we enclose the building and we put on the vapor barrier, and then we actually slowly dry out the wood using humidifiers that are basically pumping water into the air, and then we slowly turn those down. And then, because one of the key things with these wood buildings is you cannot, if you change the relative humidity of these buildings very quickly, you can have severe checking. So I think there's some issues. The other thing I want to point out is wood buildings make noise. So if you can't handle things just going every once in a while, you probably don't want to work in a wood building. So just to be clear.
Anyone else?
Question for Tom. In your photos, you showed in your office building, when you constructed it, you had these powder-coated metal connections. Most of them were hidden in the final construction, but there was a small portion that's still exposed. Did the local codes require you to put any fireproof coating on that?
No, because that building's rating is based on the sprinklers. So I think you could build it out of just steel, exposed steel, or whatever you would like it to be built out of, because it's a low-rise construction. So we have, that's how we're getting that. But it was our goal to have no steel exposed, so that effort made us understand that we needed the bearing for those big girders at the base. So if you looked at the details that we did for the framework project, we actually screwed wood from the underside of the connector onto the bottom side of that plate, and that was actually how we protected that element. We basically just imagine you just putting 3 inches of wood over the details that you saw today for the Albina Yard project. So the funny thing about that is, initially when we went into fire testing, we had layers of gypsum plate actually attached to the steel, and that failed. So we kind of came up with a solution where we're actually screwing the wood in from the steel connector. So as the fire comes up, the screws are actually holding it onto the plate as it burns. But the one thing I also failed to mention is all the details and all the fire testing that we're doing for the framework project will become public, which is a little frightening for me. But I think that's part of the idea with this project, is that all of it will be available to anyone who's interested in that particular. So one of the goals with what we were doing was to develop the simplest detail that could be fabricated by any sort of competent steel manufacturer globally.
So was the general wood cover over the steel for thermal purposes to slow the heat transfer about 3 inches then?
Yeah, I mean, we basically are meeting a 2-hour, requirement for you know, that's really what it is. It's the amount for those particular connections, the amount of wood that we need to keep the steel from heating. And basically the center of that, and that's really the thing that we're doing. We're using the wood to protect the steel, because, you know, steel is incredibly strong, great material, can be used a small amount to really create that connection.
So one of the things I was noticing in the framing details, in terms of the CLT slabs, is that you've got parallel beams, the slabs go to the edge, but you don't seem to need anything perimeter around the outside of the frame?
Yeah, that's on purpose, because, you know, like I talked about with Albina Yard, you know, we were really impressed by the cantilevering capability of CLT. So basically that's a double cantilever between the ribs. So what we're doing is we are using like a 32-foot panel that then is staggered and ties together those beams, those ribs, as they run along. So basically you're cantilevering. We can go about 15 feet with a 5-ply. And I'm sure as we get into composites, we'll go farther. But that way you can eliminate that perimeter beam and have that very simple, thin exposure at the edge. So those are some things, like, I think as people start to kind of understand the material kind of characteristics at a deeper level of what CLT can do, then you'll start to get more efficient structures. And that's really what our goal is to, I think what maybe Americans, we have issues, I should say, but I think one of the things that we are great at is the idea of creating and making structures very efficient and working to kind of get to that level of efficiency. And that's what is why we're so kind of interested and excited about this technology being part of that process.
Back?
Sorry, just a quick question. How do you deal with termites? I know that you don't have those in all countries, but we certainly have them here. And I assume you're not treating the timber itself, so you're treating the ground plane?
Do you want somebody else can answer that? Or I can. I mean, I just...
Well, I was just going to say that certainly the work that I've been doing has, as you can probably hear, has been in Europe. I arrived in Australia 3 weeks ago. And in the UK and Europe, and I suspect in North America, everybody's first question is always fire. In my 3 weeks here, everybody's first question has always been termites. So I think that definitely is something that we're going to have to address. But yeah, it's not in my experience yet.
I mean, we're working in the South too, because they're ramping up their production and they're interested in CLT. And you know, I think this is the interesting thing, is I would probably do a concrete first floor in a place where you have an issue with termites. I probably would not bring the wood down to the ground. That's me. And I think that, I don't know, you can, Philip, I don't know if you have something to add.
So in 25 King Street, everything below ground is in concrete, and the core pops up to level 1, and you would have seen the columns were raised above the ground. And in the last competition that I showed you, there was going to be retaining walls, all in concrete, so complete separation of the concrete and the timber structure. So the ground never would have touched the timber.
Although I would say that I was in Brazil a few weeks ago, and they were telling me they have species of termites that are quite happy to climb up other materials and then get going. So yeah, you might have to be careful. Right. Yeah. So I think it'll have to be some kind of
Treatment.
either a treatment or looking at species which have a natural resistance to termite. And as I understand it, you know, there are eucalypt species and things which do, although they probably present other challenges.
Time for one more question. Well, I want to thank the speakers again very much. It was a great presentation. Thank you.